is it that this integral can relate to the Euler identity? Well, this particular integral can easily be solved just by using the arctan. This is basically the tan inverse of x from 0 to 1, and you'll quickly see that this is going to be pi over 4. So this integral here is equal to pi over 4, but let's go ahead and solve this using partial fraction decomposition, because this we can rewrite as x plus I times x minus I with respect to x. So using partial fraction decomposition, we're just going to rewrite this into this right here. This is where I invite you to kind of solve this on your own. Okay, so let's go ahead and talk about this. This is pi over 4. And now this right here, I'm just going to multiply the top and bottom by I. So I, and what that's going to give us an I on the top. And then this is going to turn into 2 times -1, canceling out this negative on the outside here. So we have I over 2, and then we have the integral, and we can easily integrate this. And by the way, I forgot the 0 over 1, but this will become the natural log of x plus I minus x minus I, and then we're still integrating from 0 to 1. So using the first fundamental theorem of calculus, we get that pi over 4 is equal to, plugging our 1 here, we're going to have I over 2, and then we have natural log of 1 plus I over 1 minus I, minus natural log of negative or positive I over negative I. Now this one here will turn into -1. Natural log of the absolute value of -1 is 0, so this just go away. All right. We're not going to worry about that now. Let's go ahead and multiply the 4 to the other side, giving us pi is equal to I or 2I natural log of 1 plus I over 1 minus I, and then we still have the absolute value there. And so now what we did is just multiply the top and bottom here by the conjugate, so 1 plus I, which is going to help us simplify this right here into simply just 2I over 2, which is going to just give us I. All right, so a couple of things that I'm going to go ahead and do is I'm going to multiply both sides by I, giving us I pi is equal to, and then when I multiply this by I get -1. So this is -2 natural log of I. Let's go ahead and do a couple things by bringing this inside. So we have I pi is equal to natural log of I to the -2. And let's go ahead and talk about what that is. Y to the -2 is equal to 1 over I squared, which is just 1 over -1, giving us -1. So what we have is we have the natural log of -1. Now it's an absolute value, so this is totally valid here. Let's go ahead and take the e of both sides, and we have e to the I pi is equal to, and then when you take the e on this side, the natural log goes away, giving us a -1. We bring this to the other side, and we have e to the I pi plus 1 is equal to 0. The Euler identity that was given to us through this integral right here. That's pretty cool.